Hello and welcome to IoT based home automation project under EMERTXE, and this project is done by SANDEEP Kumar Reddy, ANUSHA, MOHNISH, KAMALAKSHA and BHARGAVA. In this PPT we will cover the topics of home automation using Arduino, that is the PixMake lab, and Blink application, controlling garden lights based on whether it is day or night, controlling cooler and heater based on whether it is hot or cold, also sending respective notification to LCD and mobile application, controlling water level of the tank based on its capacity, and also sending respective notification to LCD and mobile application. So let's begin. Now what we have learned in this internship. In the first week we were taught about C programming and its data types, about conditional statement and different types of operators, pointers and functions, string manipulation and storage classes. This internship was over for 4 weeks, and in the first week we covered these topics. Now C programming. C programming, where it's used and its characteristics were taught to us. The keywords that we will be using were the basic data types, modifiers, qualifiers, loops, jumps, etc. Data representation, basic data types, conditional constructs, operators, arrays and pointers. Then we learnt about embedded C, in which we were taught about recursion, constant with pointers and strings, embedded C about preprocessors, UDT structures and storage classes. In the week 2, we were covered about C++ classes and object creation in C++, about constructors and destructors, introduction to IoT and its application, including the installation of Arduino IDE, null modem emulator, PixSim lab in which we have done the simulation, and all other required libraries. Week 3 and week 4 was spent building our home automation project. Introduction to IoT. Internet of Things, or IoT as it's called, is the network of physical objects that contain embedded technology to communicate and sense or interact with their internal states or the external environment. These devices range from ordinary household objects to sophisticated industrial tools. With more than 7 billion connected IoT devices today, experts are expecting this number to grow to 10 billion by 2020 and 22 billion by 2025. By means of low-cost computing, the big data, analytics, and mobile technologies, physical things can share and collect data with minimal human intervention. In this hyper-connected world, digital systems can record, monitor, and adjust each interaction between connected things. The physical world meets the digital world and they cooperate. IoT architecture. In this architecture, we can look at the gateways, about clouds, how the control applications interact with big data warehouses and sensor data, about how machine learning is involved, data analytics, user business logic, web application, and mobile application. This gives us a brief idea about the architecture of IoT and how it functions or works. Now, coming to embedded systems. What is embedded system? An embedded system is a combination of hardware and software which is intended to do a specific task, can be called an embedded system. It has three parts: software, firmware and hardware. Unlike computers, embedded systems perform few specific limited tasks. Embedded devices have peripherals such as serial communication interfaces (SCI), synchronous serial communication interface, universal serial bus (USB), multimedia cards, that is SD cards, compact flash, etc. Now coming to the purpose. The purpose of this document is to understand the requirements of home automation using Arduino and Blink application. This document will be used by students to develop the project. This document will also be used for requirement validation. The scope. The home automation should be simulated on the PixMake simulator. Blink IoT mobile applications used to control the devices should be able to control lights, temperature of the home, inflow and outflow of the water in the water tank. Basically, the scope of the project that we will be doing is to do home automation, in which we will be handling three things, that is controlling lights, temperature of the home, and inflow outflow of water in the water tank. Now, what are the assumptions? All the peripheral devices are simulated and no real-time objects are interfaced. Dependencies are it's based on the Blink app we are controlling devices, for which we use Blink IoT, which is an open source tool. Now, the requirements. What are the software requirements that we have used in this project? Arduino IDE, in which we have written our code in C language. Pix Lab for simulation, in which we have selected LCD HD 44780. Null modem emulator to configure port of serial removal tank, and the Blink IoT app, which acts as our cloud server. Hardware requirements: Arduino Uno ETHW5500, PCF8574, temperature sensor, LCD HD 44780, LDR sensor, and an LED. As you can see in the functional requirements, Blink mobile app is interfaced with the Blink cloud server, which in turn is simulated with our Pixmix lab. So using our mobile Blink IoT mobile app, we can control the functions of Arduino Uno using the Blink cloud server, for which we use the authentication token to form a connection between the Arduino and the mobile app, and indirectly we can control the requirements in the code. So first scope is the garden light control. So in this, we actually have to read the LDR sensor value. Based on the reading from the LDR, we need to vary the brightness of the LED, which resembles controlling the garden lights based on the availability of sunlight. As we can see in the diagram that's given below, first the Arduino Uno will take in input from the LDR sensor. Depending on how bright or how dim the outside world is, Arduino Uno will increase the brightness of the lights. Secondly, temperature control system. The temperature control system consists of a heating resistor, an LM35 temperature sensor, and a cooler, which resembles the temperature control system at home. Re- Firstly, read the temperature from the temperature sensor LM35 and display it on the CLCD. Control the temperature on the system by turning on and off the heater and cooler through the Blink IoT mobile app. Now, as we can see in the diagram given below, first the Arduino uses the temperature system, which is a collection of the sensor and the output devices, to take in temperature readings and give out the heater control and cooler control. The CLCD is actually an interface which will help the user to see what the temperature is at home physically. And after that, Blink IoT also is interfaced with Arduino Uno to help control the temperature and also to help receive notification. All this works as a symbiotic relationship between the temperature sensor, Arduino, CLCD, and the Blink IoT app. And lastly, the user interfaces. The Blink application. Blink was designed for the Internet of Things. It can control hardware remotely, it can display sensor data, it can store data, visualize it, and do many other cool things. Create widgets on mobile Blink application. Button widgets are used to control the heater, cooler, inlet valve, or outlet valve. Gauge widgets are to display the temperature and volume of the water in the tank on the mobile application. Terminal widgets to display the notification whenever threshold is crossed, like temperature is more than 35 degrees, turning off the heater, water level is full, water inflow is disabled. So we make use of three widgets for this project, that is the button widget, gauge widget, and terminal widget. This is how it looks on the Blink IoT app. So here we can see that the button widgets are used to control the inlet valve, outlet valve, and gauge to display volume of water in the tank, and terminal to print the notifications. As you can see, we have used the buttons over there as on, and we can check out the level of water over the meter. Similarly, even in the second diagram, you can see that the budget widgets are used to control the heater, cooler, and gauge widget to display the temperature. Coming to Arduino Uno. Arduino Uno is based on an 80 mega 332 8P microcontroller. It is easy to compare using other boards such as Arduino Mega board, etc. The board consists of digital and analog input or output pin shields and other circuits. The Arduino Uno includes a 6 analog pin input, 14 digital pins, a USB connector, a power jack, and an ICSP in-circuit serial programming header. It's a program based on IDE, which stands for Integrated Development Environment. It can run on both online and offline platforms. Now, this is a picture showing Arduino Uno that we have used in our project, but as of now we have only used it as uh, a simulation in Pick Simulator. As you can see in between, you can see uh, a black device which is actually the microcontroller that we will be using. As before, it is the 80 MegaThread 2AP microcontroller which is used in an Arduino Uno. This you can see is the power cable. Here an orange button is the reset button. This is used for ISP communication protocols. Here you can see the power inputs. As you can see, it's written 5 volts, 3.3 volts, 5 volt, depending on different needs of the user. Here you can see analog pins and digital pins separately, as well as two pins dedicated for transmission and receiving. Now moving on, about ETHW550. The W5500 chip is a hardwired TCP/IP embedded Ethernet controller that provides easier Ethernet connection to embedded systems. W550 enables users to have the internet connectivity in their applications just by using the single chip in which TCP/IP stack 10 out of 100 Ethernet MAC and PHY is embedded. It supports power down mode, supports wake on LAN over UDP, supports high speed serial peripheral interfaces, the SPI mode 0,3. Now, talking about PCF8574. It is a silicon CMOS circuit. It provides a general purpose remote input-output expansion for most microcontroller families via the two-line bidirectional bus. The device consists of an 8-bit quasi bidirectional port and a 12C bus interface. The temperature sensor. A temperature sensor is an electronic device that measures the temperature of the environment and converts the input data into electronic data to record, monitor, or signal temperature changes. Here we are using the temperature sensor and convert it into degrees so that the user can easily understand what the temperature is inside the room. Threshold control. When the heater is on, if the temperature rises above 35 degrees Celsius, the heater should turn off automatically and message temperature is more than 35 degrees Celsius. Turning off the heater should be displayed on the virtual temperature HT_R off on CLCD. When the water is in the tank is full, turn off the inlet valve automatically and display water level is full, inflow disabled. The threshold controller is an important part in IoT as it makes the device user friendly and the user does not need to always check on the level of the temperature or the level of the water. As spoken before, this is the notification that we will get uh, based on what the temperature level is and what whether the inflow or the heater is off or the heater is on, which is given by HTR on and INFLO. So it tells us if the inlet is flowing or not flowing. This is the project images that we have attached. As you can see, one of the pictures shows us about the tank level. Similarly, we can see the CLCD that we have also kept, and the fan shows us about the temperature system that we have created. Moving on, again we can see it in a much clearer. This including the snapshot from the mobile that shows us the home automation and every images from the PixSim lab and the tank. So, what is the conclusion of this project? Now, using the Blink IoT application and PixSim Lab simulator, simulated home automation where LED temperature system serial tank resembles light, heater, cooler, and water tank in real time. CLCD acts like a dashboard using for displaying the events. Widgets from Blink IoT app like button widgets are used to control heater, cooler, and inlet valve and outlet valve. Gauge widgets to display the temperature and volume of the water. So indirectly, we did this IoT project to design a home automation system which could be easily designed using C programming language and using an Arduino IDE to write code in and Pixim Lab to actually simulate the environment. Thank you.